Hello viewers, welcome to EF. Today I would like to discuss about the informal definition of Turing machine and some question related to it. Now in my previous video you already have been watched about different kind of proof and definition of what is decidable decision problem and undecidable problem. In my next video you will see um, some example of decidable decision problem and the complexity of that. So before discussing about the P and NP or NP complete problem, it is necessary to know about what is Turing machine. That's why I started to discuss in this video. So you know that what is Turing machine? Turing machine is a mathematical model for computer program, you can say, and it has open in both sides. Infinite tape, it's an infinite tape open in both sides. On the tape at the beginning, the input is stored. It has a read write head which will put a certain position of the input type of the computation. It has a finite set of states. It has a transition function delta, and it has a current symbol. Like here I have mentioned that sigma is my current symbol and pointing to the particular cell which is P. So, and if we say the sigma star is the input that we are giving to the tape, and it could be 0 or whatever you want the symbol. So that is the informal definition of Turing machine. Now, the question is how it works. Well, basically, depending on the current state and current symbol, what Turing machine does is it it works with the transition, what the transition function is saying, and transition function moves into another state from the current state and replace the current symbol by a new symbol. So how the read write head is worked? Actually, the read write head is pointing to three movement: left, right, or no movement. So you can see that the delta is pointing here. The current state is P and the symbol is current symbol is sigma, as you can see in this picture. Now, if I want to use the transition function, my next symbol will be sigma star, while the next state will be Q, and the read write head can be left, right, or no movement. So this is how the Turing machine work based on the transition function, current symbol, and the current state. Now the question is, can we create a model of Turing machine without n, means without no movement in the head? Of course, the answer is yes, we can make, but the problem is here. There will be no actually there will be no big problem. The construction of the Turing machine will be the same. Only the difference will be on the number of steps. Like in that case, we need to create a um, new state, and then we can move it the state into the left or right, and then we come back to the no movement position where we were before. So it's basically saying that just increasing the number of steps, but without n doesn't affect on what the Turing machine is doing. But in that case, we need to take two more steps instead of one step. To have n is not necessary because transition table will be a little bit longer, more, nothing else. It will not necessary to have n, but the computation time will be more. So it's better to have a no movement state. We can say that in how can we make it? We can make a set of state. Suppose we have a set of state q prime, and we will construct a new state q prime, and then we can make this this p prime which belongs to the original state, and in that case we will have an additional. However, the situation will be the same, like one movement more, and it can also cause the situation that the Turing machine are stuck at the same position. So finally we can say n will not affect, uh, only the number of steps will be increased. Now the next question is, if we only move the head on the right side and replace sigma by sigma prime, what will happen? The answer is, if we do like that, only if we move the head on the right side, and if we replace the sigma symbol by the sigma prime, then actually the it will break the model, and it will not effective. So can we read so in that case we can only read the sigma and sigma prime once at the one direction, and later it will be no more use. And moreover, it will make the Turing machine limited, and no more use of the proper use of the head, because the fundamental policy of Turing machine is that we should use the read write head on the left and on the right side for the movement. Now there is another interesting question. Does the Turing machine is algorithm, or is it fulfill all the properties of algorithm? Now you know that the algorithm should contain, in my previous video I already explained that algorithm has five properties: input, output, effectiveness, definiteness, and finiteness. Now only the finiteness property is doesn't match, because once we are putting the arbitrary input into a Turing machine, we doesn't know when it will be terminated, and it will also cause the halting problem. You know about that. So algorithm and Turing machine is almost doing the same, but the output terminate creates the halting problem. And I can define the halting problem as input for the Turing machine and input for the Turing machine, and output is yes only if the Turing machine goes to the final state Q yes or Q no. That particular input or particular output is no or yes. You can show that the problem of course halting problem, that is undecidable using Turing machine. So basically we can say that the Turing machine is decidable for particular set of machine, but for an arbitrary grammar something can be generated or not, and it is undecidable. So it can be solved by halting problem only. So we can say that finiteness property of the algorithm does not covered by the Turing machine. So thank you for watching this video. In the next video, I will discuss about the formal definition of Turing machine, and later on we will discuss about the complexity of the Turing machine. See you again.